Hi. So now to understand this question, we'll have to do a little bit of generalization here. The question is the largest real value of a for which this expression is equal to 2 has an infinite number of solutions for x. So this has an infinite number of solutions of x, and we have to figure out the value of a such that we get infinite values of x. Now let's try to generalize this first. Let's take a general expression of similar type. So let's take x minus p plus x minus q is 2, and then we'll see whether p is minus 1 and q is minus a, or q is minus 1 and p is minus a. We'll look for it later, but let's just generalize this right now, considering that q is greater than p as of now. Fine. So if this is true, now the critical points here are when these terms are 0. This is 0 when x is p, and this is 0 when x is q, and considering that q is greater than p. So we'll have three cases basically here. The critical points are p and q, right? So we'll have three cases. First case is when x is greater than or equal to q, second when x is between p and q, and the third when x is less than p. Okay, so the first case is when x is greater than equal to q. If x is greater than equal to q, the term inside this mod is positive and the term inside this mod is also positive. Both of them are positive, so mod will be removed as it is. So we'll have x minus p plus x minus q is 2. This is the first case, right? So we'll have x minus p plus x minus q is 2. For that we'll have 2x minus p minus q is 2. So from here we'll get x is equal to 2 plus p plus q by 2. Now since p and q are constants, we get only one possible value of x. So if such is the case, we get only one possible value of x, only one root. But what we want is infinite solutions for x. Okay, let's take the second case where x is between p and q, right? Now if x is between p and q, this term is positive but this term becomes negative. So mod of x minus p will be x minus p, but mod of x minus q will be minus of x minus q. So this will become minus of x minus q will be minus x plus q, right? So now x minus x gets cancelled out. We have q minus p is equal to 2. Now if the values of q and p are taken such that the difference is 2, then this will be true for all values of x in this range. For example, let's take q is equal to 3 and let's take p is equal to 1. If q is 3 and p is 1, then for any value of x between 1 and 3, this will always be true. So for this situation, we get x can take any value between 1 and 3, so x will take infinite values. It can be 1 3, it can be 2 4, it can be 0 2, it can be minus 1 1, anything. We don't know the exact values, but the difference between q and p is 2, and for that we get infinite values of x. X can take any value between these two terms, right? So we have, this is true for all values of x in this range, hence it has infinite solutions. And finally, if x is less than p, that is this case, then both these terms will be negative. So mod of will be removed by putting a negative sign here. So we'll have minus x plus p and minus x plus q is 2. So we'll have minus 2x plus p plus q is 2. So again from here we'll get a single value of x. We'll get a single solution of x. We will not get infinite solutions. Since we want infinite solutions, we get infinite solutions only from this case. So this must be the case. What is the case? The case is that the difference between the two constants here is 2, right? So now let's come back to the equation that we had. Now this can be written as mod of x minus of minus a plus mod of x minus 1, which is 2. So what we now have is, for this equation to have infinite solutions of x, the difference between minus a and 1, the difference between p and q should be 2, right? So the difference between minus a and 1 should be equal to 2. So the difference between minus a and 1 is nothing but the distance between minus a and 1, right? So this should be equal to 2. So there are two possibilities. One is that minus 1 is greater, or either 1 is greater or minus a is greater. We have to figure out the difference between these two, right? So either 1 is greater than minus a or minus a is greater than 1. So if minus a is greater, we'll have minus a minus 1 is 2. Or if 1 is greater, we'll have 1 minus of minus a is 2. So if this is the case, we get a is equal to minus 3. And if this is the case, we get a is equal to plus 1. So the value that a can take is either minus 3 or plus 1. Minus 3 is not there in the options. Only option D, 1 is possible. So for a equals to 1, what we'll get is, we'll get x minus of minus 1 plus mod of x minus 1 is equal to 2. And if this is the case, we'll have infinite solutions of x when x is between minus 1 and 1. When x is between minus 1 and 1, we'll get infinite solutions of x over here. Okay? Now let's try to understand the same thing from a slightly different perspective. We know mod of x minus, let's say, some number 2 is basically the distance of x from 2, right? That's what mod tells us. So mod of x minus 1 is the distance of x from 1. Let's say this is 1, and mod of x plus 1 can be written as mod of x minus of minus a. So this is the distance of x from minus a. Now a can be on the left side of 1 or it can be on the right side of 1. Both of them are possible. Let's just for the time being assume it is on the left side of 1. So now if x, now what is mod of x plus a? It is the distance of x from minus a, and mod of x minus 1 is the distance of x from plus 1. Now if you take x on the right side of 1, if x is somewhere here, so mod of x minus 1 is this distance and mod of x plus a is this distance. So sum of these two distances should be equal to 2. Now this will be possible only for a particular value of x. This distance plus this distance. As you increase x, this will also increase and this will also increase, right? So there will come a point that when the distance is 2, and after that the sum of the distances will keep increasing. So there will be only one particular value of x for which the total distance will be 2, but not infinite solutions here, right? So x cannot be to the right of the least of the values. What if x is to the left of the, x cannot be to the right of the highest value? What if x is to the left of the least value? What if x is here? This is minus a, this is plus 1. Now again x plus a is this distance and x minus 1 is this distance. So again this whole thing is the sum of the two distances, and as you take x towards left, the individual distances will increase, hence the sum will increase. So there will be only one particular value of x for which the distance will be exactly 2 and not infinite values here, right? So even here you will not get infinite values, here you will not get infinite values. What if x is here? Now if this is 1 and this is minus a, and if you take x somewhere here, the distance x minus 1 is this distance and x plus a is this distance. Now if you take x anywhere from here to here, the sum of these two will be basically the distance between minus a and 1, right? This plus this distance, or even if you take x over here, you are basically adding this distance plus this distance. So in any case, what you are doing is you are effectively calculating the total distance between minus a and 1, right? And this distance will always be same wherever you take x in this range. So for any value of x, the distance will always be same. And for the distance to be 2, you'll have to take values of minus a such that this distance is 2. So if this total distance is 2, for any value of x, the sum of the two distance will always be 2, right? So that's why what we did was, if this is minus a and 1, the distance between these two values should be 2. As in the difference of these two values should be 2. Now either minus a can be less than 1 or greater than 1. If minus a is greater than 1, we'll form this equation. If minus a is less than 1, we'll form this equation. The distance between these two critical points should be 2, and if x is between these two critical points, the distance of x from both these points, the sum of the distance of x from both these points will be 2. Right? So what we need to do here is basically calculate the distance between 1 and minus a, which are the two critical points here. So you'll get two different values of a, which is minus 3 and plus 1. So this is how also you can understand the same three cases. Thank you.